Right, TrueNAS, new series. Let's kick off.
February 2026. A user imports a storage pool. The import triggers uncorrectable failures. The metadata corrupts. The interface crashes. Hard resets required. The pool sometimes re-imports and begins repairing itself, but the system remains unstable. This is not the only incident. January 2025. A pool randomly corrupts after a system update. May 2025. A pool degrades after updating between versions with a disk marked as faulted and no hardware errors to explain it. Then March 2024, a major technology publication runs the headline that the platform has abandoned the operating system it was built on. TrueNAS, the storage platform that launched as FreeNAS in 2005. 15 years as the community standard for serious data integrity, the storage architecture remains exceptional. The updates that sit on top of it have become the risk the storage was designed to prevent. FreeNAS began in 2005 when a developer built a lightweight storage server on a Unix-based operating system. The product spread through the open-source community as a way to turn commodity hardware into a capable network storage device without paying for proprietary appliances. In December 2009, a privately held storage company acquired the project at a transition point and kept the Unix foundation. The business model separated the Community Edition, which was free, from the enterprise hardware and support, which generated revenue. By 2022, the company reported 100 million in bookings. The Linux-based edition reached general availability in February of that year. In October 2024, the release codenamed Electric Eel replaced the container orchestration system with a simpler container runtime and introduced single-drive expansion for storage arrays. In April 2025, the release codenamed Fangtooth unified the community and enterprise editions. The company rebranded under the product name. The trajectory is clear. The Unix-based edition that built the community trust is in sustaining mode with no further feature development. The Linux edition is the future. The community that chose the platform specifically because of its Unix foundation was told the foundation is changing. A third-party application catalog that had provided the broadest container selection on the platform deprecated its support after the container runtime change, further reducing what was available to users who had built workflows around it. The update-triggered pool degradation is the failure pattern that matters most because it contradicts the platform's core promise. The storage file system is designed to protect data through checksumming, redundancy, and self-healing. When an operating system update causes a pool to degrade, the failure is not in the storage layer. It is in the software layer that sits above it. The storage did not fail. The update made the storage appear to fail. In September 2024, 2 drives entered a removed state after an update. In January 2025, a pool corrupted after a point release. The user had to reconfigure applications and rebuild settings. In May 2025, a pool degraded during a version upgrade with a disk marked as faulted despite no hardware errors on the diagnostic tools. In November 2025, applications stopped functioning after an update because the container runtime lost network connectivity. In February 2026, the pool import that triggered uncorrectable failures and crashed the interface. The March 2024 Deprecation headline is the institutional event the community references most. The Unix-based edition entered sustaining engineering. The final release was published. Users who had built their storage infrastructure on the assumption that the Unix foundation would continue were told to migrate to the Linux edition. The migration path exists. The trust cost of being told to leave a platform the user specifically chose does not have a migration path. The build system moving from a public repository to an internal one compounded the concern. For a product built on open-source transparency, reducing that transparency is a signal the community tracks. The storage architecture beneath the update concerns is the reason the platform remains the standard for serious home storage. The file system provides copy-on-write snapshots that capture the state of the entire pool instantaneously. Block-level replication sends those snapshots to a remote system for off-site backup. Scheduled integrity checks detect and repair silent data corruption before the user encounters it. Redundancy configurations protect against 1, 2, or 3 simultaneous drive failures, depending on the level chosen. The single drive expansion feature introduced in 2024 allows gradual capacity growth without rebuilding the entire array. For protecting data against hardware failure, bit rot, and silent corruption, no other platform in this comparison provides the same depth. The application layer has been the source of friction since the container orchestration change. The 2024 release replaced the previous orchestration system with a simpler container runtime. A third-party application catalog that had provided hundreds of community-maintained containers deprecated its support for the platform. The official application catalog is smaller. Users who had built workflows around the previous application ecosystem found those workflows broken. The current application experience is functional but narrower than what was available before the architecture change. The sharing capabilities cover the enterprise and home use cases. Network file sharing for consumer devices, the Unix network file system for Linux and server environments, block-level storage access for virtualization. The newest protocol provides direct memory-mapped storage access for high-performance workloads. The sharing layer is mature and well-tested across 15 years of deployment. Someone whose primary requirement is data integrity, who needs snapshots, replication, and protection against silent corruption, should use this platform. The storage architecture is the strongest in this comparison. No other platform provides the same combination of checksumming, redundancy options, and block-level replication. The recommendation carries a specific operational requirement. Snapshot before every update. Test major version upgrades on non-production hardware if possible. Accept that the update layer carries risk. The storage layer was designed to prevent and mitigate accordingly. Someone migrating from the Unix-based edition to the Linux edition should follow the documented migration path and verify the pool imports correctly on the new system before decommissioning the old one. The migration is supported. The documented pool import failures in the research period mean the user should not assume the import will succeed without verification. Keep the previous installation intact until the migrated system has been running stable for a period the user defines as sufficient. Someone who needs a broad application ecosystem should understand that the container catalog is narrower than what was available before the 2024 architecture change. The third-party catalog that provided hundreds of community containers no longer supports the platform. The official catalog covers the most common applications. Users whose workflows depend on specific containers should verify availability before committing. Someone evaluating the build system closure should understand what changed and what it means. The source code for the platform remains open. The build system, the tooling that compiles and packages the source into an installable image, moved from a public repository to an internal one. The user can still read and audit the source. The user can no longer independently build the distribution from the public repository without additional effort. For users whose trust model requires fully reproducible builds from public infrastructure, this is a material change. The platform that began in 2005 as a lightweight storage server and grew into the community standard for serious data integrity carries a tension in 2026 that its founding did not anticipate. The storage layer, the file system, the snapshots, the replication, the checksumming, these work. They are the reason the platform earned its reputation over 15 years. The software layer that sits above the storage, the updates, the application runtime, the build system decisions, these are where the community's trust has been tested. The disks are trustworthy. The decisions around the disks are where the questions live. For the user who needs the strongest storage integrity available in a home server platform, the architecture delivers. The operational discipline of snapshotting before every update and verifying after every migration is the cost of using a platform whose storage is excellent and whose update history is not.